Hi guys, welcome back to another chemistry lesson. In this video, we're going to talk about significant figures. So when I was in college, I learned how to figure out the number of significant figures using a long list of rules, and you kind of just had to check what applied, and you would figure out that way. I am proposing to you a much easier way to figure out the number of significant figures, and it involves a map of the United States. So if you're from the United States, you hopefully know that on the left-hand side near California is, over here, we've got the Pacific Ocean, which is labeled there, but I wrote it here for you. And then on the right-hand side, we've got the Atlantic Ocean, which I've written here for you. If we use those sides, we can use some alliteration to help us with this. So Pacific Ocean, this is when we are talking about if the decimal is present in the number that we are looking at. For the Atlantic Ocean, this is for if we are looking at a number where the decimal is absent in the number. Okay? So what you're going to do is you're going to take whatever number you have. I'm just going to make up a number here. 5, 4, 3, 1, 0, 0. Right? You're going to look at your number, determine if the decimal is present or absent. In this case, I do not have a decimal anywhere in the number, so it is absent. So I'm going to start on the Atlantic Ocean side of the number. You go until you get to something that is not a 0, and then you count every digit after that. So in this case, that number would have 4 sig figs, or significant figures. Right? So let's practice some. So again, Pacific on the left, Atlantic on the right. The number 4,050, here we have no decimal. So I'm going to start on the absent side, go till I get to something that's not a 0, and I count 1, 2, 3. This number has 3 sig figs. All right, the next one. Here I do have a decimal, and I'm going to actually highlight it there for us. And so we're going to start on the Pacific side of that number because the decimal is present in this number. All right, I go until I get to something that is not a 0. 1, 2, 3. This number has 3 sig figs. You will notice that once I started counting, even though I got to an additional 0, I did not stop counting. Once you start counting, you don't stop, even if it is a 0. All right, for scientific notation, it's just however many numbers are in the base of your scientific notation. So here, there are 4 numbers, therefore 4 sig figs. All right, this next number, the decimal is present. It's right here. So I start on the Pacific side, go until I get to something that's not a 0, which in this case happens to be the first digit. And then I count. There are 3 sig figs in that number. All right, next number. I have a decimal. It's very tiny, but it is there. So I'm going to start on the Pacific side, go till I get to something that's not a 0, and then count from there. 3 sig figs. And then for this final example here, I have a decimal, so it is present. Start on the Pacific side, go till I get to something that's not a 0, and then 1, 2, 3, 4, 5. There are 5 sig figs in that number. Okay, so once I have my significant figures, I'm going to have to be able to do math with those. So here is our first rule. Addition and subtraction problems, we are looking at, and I'm going to make this a little bit bigger here. All right, addition and subtraction problems, we are looking at the least number of decimal places. All right, significant figures are all about being able to look at how precisely you know your numbers. So off the top of your head, maybe this doesn't seem like it addresses significant figures, but if I'm measuring, let's say, a distance, if I say 100 meters versus 100.00, the more decimal places I have, like this one, the more specifically I know that number. Right? So this is Sig Figs, even if it doesn't immediately seem like it is. Oops. I just want to scooch this out of the way. Oh no. Okay, well, I'm going to erase it then. Okay, so what you want to do is you want to do the math. So 12.4 plus 3.56 gives me 15.96, right? So get your answer however you get it, with however many decimal places you get it. Then you want to look back at the numbers that you were working with in the problem, right? 12.4 has 1 decimal place. 3.56 has 2 decimal places. Your job is to round your answer so that it matches the least number of the least number of decimal places. So in this case, 1 decimal place is the least number of decimal places. So I want to round to that first decimal place. So when I do that, 6 tells the 9 to round up, which would be a 0 because this would round to 16. So 16.0 is the final answer for that question. We have taken that same number and rounded it at the 1 decimal place. All right, the next question, we have 250.0 minus 0.056. This gives me 249.944. All right. 250.0 has 1 decimal place. 0.056 has 3 decimal places. My job is to round it to match the least number of decimal places from my problem. So in this case, I want to round to that first decimal place. If I do that, I get 249.9 because the 4 tells the 9 to stay the same. Right. This brings up, and I didn't mention in my previous question, but I'm going to mention it here. Any extra numbers that you have after the decimal place when you're rounding, you drop them. So previously that 6, it got dropped. This number here, it gets dropped. Okay. If I have an extra number once I round before the decimal place, I need to turn it to a 0. And I'll get to that in the multiplication and division questions. But for now, you need to know that whenever we have extra digits after the decimal place, like we did here and here, you turn them into a 0. All right, a couple more addition and subtraction questions. 3.008 plus 4.02 gives me 7.028. All right, in my problem, 3.008 has 3 decimal places and 4.02 has 2 decimal places. I want to match the least of that, so I need to round to the second decimal place. All right, the 8 tells the 2 to round up, and then we drop the 8, so 7.03 is my answer here. And then finally, 7.005 minus 2.1 gives me 4.905. 7.005 has 3 decimal places. 2.1 only has 1 decimal place. So my answer should match that and round to the first decimal place. If I do that, I get 4.9. I drop the 0 and the 5. So 4.9 is the final answer. Okay, now, when we're talking about multiplication and division, we want to, I'm going to call it the philosophy behind it is the same. We want to match the least from our problem, except for multiplication and division, we're looking at significant figures. So least number of sig figs from the problem. All right, so this first question, 4.50 times 0.020 gives me 0.09. And let's see. 4.50 has 3 significant figures. 0.020 has 2 significant figures. So this answer should have 2 significant figures. Currently, it only has 1. To make an equivalent number that has 2 significant figures in this situation, I have to add a second 0. So 0.090. All right, the next question, 15.0 divided by 0.003. I get 5,000. 15.0 has 3 sig figs. 0.003 has 1 sig fig. That is 1 significant figure. So that is my answer. Sometimes you don't have to round. Sometimes you do. All right, the next question. 0.0080 times 3.44. The answer is 0.02752. 0.0080 has 2 significant figures. 3.44 has 3. So my answer should have 2 significant figures. When you're trying to figure out where that second significant figure is, you're going to start on the left-hand side of the number and find the second significant figure from there. So these 2 numbers are not significant until I get to the 2. This is significant figure number 1, significant figure number 2. So this is the point at which I need to be rounding. All right. The 5 tells the 7 to round up. I'm going to get 0.028, drop off the 5.2, and that will be my final answer. All right, and this final question is 6.070 divided by 4.2. That gives me 1.445238095 is what my calculator gives me. All right. That question or that number has 4 significant figures. This one has 2. So I should round at the second significant figure place. Again, we start on the left for this. 1, 2. So this is the location I'm going to be rounding. That 4 tells that 4 to stay the same. I get 1.4, and then I drop all of the other digits. And that's the answer. All right, let's talk about multi-step math problems, right? The thing with multi-step math problems is you have to write down your in-between numbers And you have to acknowledge what you're doing, and then go from there. So 7.005 plus 2.1 times 4, right? So we have two different types of math and two different rules that we have to follow, right? So we are going to, do the traditional PEMDAS, sorry, brain fart, PEMDAS, parentheses, exponent, multiplication, division, addition, subtraction, order of operations, right? First in order is our parentheses. So when I do that math in the parentheses, 2.1 times 4, I get 8.4. So 7.005 plus, and it's actually 8.40 is the number that we get, right? So as we're moving forward, I look at it and acknowledge that this is multiplication. So I want to match the least number of sig figs in that math. So my final answer, if that was the only portion of the math, if this was the only portion of the math we were doing, is multiplication, I should have 2 sig figs, right? So I'm going to go ahead and acknowledge that spot in my answer as I write it down, right? But then, now I'm doing addition. All right, so 7.005 plus 8.40 gives me 15.405. This is addition and subtraction. Therefore, I'm going to look at the number of decimal places. So if that was the only math I was doing, this guy has 3 decimal places, and this place would have been 1 decimal place. 3 or 1, I want to match the least, so 1 decimal place. So I'm going to round to this place. That tells it to stay the same, 15.4, and I drop the 0.5. So we're doing both rounding things, but you don't want to actually do the rounding until the end of your math. Because when you start chopping off decimal places, that starts affecting the math that you're doing. It starts affecting the answers you're getting. All right, let's do another one. So next I have addition. Let's see. I have addition and I have multiplication. Again, addition, we're looking at decimal places, which in this case I have 3 versus 1. So I'm going to end up with 1 decimal place for this part of the math. And then for multiplication, I look at sig figs. All right, in this case, I have 2 sig figs. We have yet to see for our parentheses. Okay, so parentheses first, 19.403 plus 2.0 gives me, I've got 21.403 times 0.0030. All right, so if I was rounding to the number of decimal places, that would be here, because I should have 1 decimal place, right? So that's the 4. All right. If I did that, this has 3 significant figures. So 1, 2, 3. And this has 2 significant figures. So my answer should match the least number of significant figures. So I'm going to take that entire number, 21.403, times 0.003. And what I get is 0.064209, which I will then round per our Sig Fig rounding rules to 2 sig figs. All right, this is my second significant figure. 2 tells it to stay the same, so I get 0.064 and eliminate those other digits. And one more math problem just for funsies. All right, this is multiplication. So I'm looking at sig figs. In this case, that guy's got 3, this guy's got 2. So my answer to that problem should be rounded to 2 sig figs. Then, subtraction, we're looking at decimal places. This guy has 1 decimal place. We're going to have to see about the other one before we can say where we round it. So, parentheses first, 4.5 times 0.02. I get 0.09000. Okay. Now in this question, I'm looking to round to 2 significant figures. That was a bad choice of color, sorry. 2 significant figures, which would put me rounding here. So now I have 250.0 minus 0.09000 rounded to that spot. All right, so again, decimal places. This 250.0 has 1 decimal place. The 0.09000 has 3 decimal places if I round it to that place. So I want to match the least. I want 1 decimal place in my answer. All right, so again, if I rounded at that 0, that would be 3 decimal places. This one I don't have to if I have 1 decimal place. So I just do the subtraction. 250.0 minus 0.09000. I get 249.91. I wanted 1 decimal place. That's here. So the 1 tells the 9 to stay the same. Get 249.9, drop the 1. Okay, one last thing. I said that I would address some more rounding things. So really quickly, if I have a number like 4, 5, 6, 1, 2, 3, 0, 0, 5, whatever. If I'm trying to round this to, let's say, 3 significant figures. All right, the 3rd significant figure is here. So 4, 5, 6, because the 1 tells the 6 to stay the same. Up here, I've been saying, oh, we're going to drop those digits. Oh, we're going to drop those digits. And that's true. If they are to the right of the decimal place, you know what? Let me just 0.1 there. I'm going to drop that. But what do I do with these numbers? Because they're not to the right of the decimal place. When you have extra digits to the left of a decimal, after rounding, turn them to zeros. So in this case, I've got 6 digits. Turn them to 0. And then I'll drop that 0.1. So there are 2 questions to ask yourself. Is this number equal to the number I started with? And is this the right number of sig figs? Because it would be very easy to flip-flop those rules, right? And to just drop those, right? If I drop those, then I would have the number 456. So then I ask myself, is 456 the right number of sig figs? Sure, that's 3 sig figs. But is 456 essentially equal to 456,123,005? 456,123,000. Are those the same thing? By asking yourself these two questions, you will be able to determine on your own if you have done your rounding with significant figures correctly. And that's it for our sig figs.